Welcome to lesson 1.4. In this lesson, we're going to expand on the unit circle and everything we learned in 1.3. So let's start with a couple equations. First off, we learned from our unit circle, we know that sine of theta is the y value, and we know cosine of theta is the x value. From that, we also know tangent is y over x. Now, this should make sense if we think of the unit circle. Here's my unit circle, and let's put an angle on it. So if I think of this point and I make my triangle, we talked about last time that this is the x side of the triangle, and this is the y side of the triangle, and we know the hypotenuse is 1. Now, if I do SOHCAHTOA on this triangle, that's where I get sine is opposite over hypotenuse, so the sine value is y. Ka is adjacent over hypotenuse, that's where we get cosine is x. And now if we do TOA, opposite over adjacent, that gives us our y over x. That's where we get tangent is always the y over x. Now, we also know that the reciprocal functions, cosecant, secant, and cotangent, are still just that value flipped, just like we've done in previous lessons. Find the sine, flip it, and you get the cosecant. Find the cosine, flip it, you get the secant. Find the tangent, flip it, you get the cotangent. Now, a couple more identities or equations that you need to have in your pockets. First up, tangent is sine over cosine, which makes sense because we know tangent is y over x. Sine is y, cosine is x. Which would make cotangent cosine over sine, because cotangent is tangent flipped. That also tells us that secant is 1 over cosine. Just take the cosine value and flip it. And cosecant is 1 over sine. Take the sine value and flip it. And these are the first equations you have on your first memory test. We have the definitions of our functions, we have our quotient identities, and our reciprocal identities. Now, having all of that in mind, let's go back to practicing with the unit circle. So here I have secant of 60. And I know that 60 is going to be in the first quadrant. And more than that, I know 60 is going to be closer to the y-axis than it is to the x-axis. So I'm trying to draw this proportional. I know where 60 is. It's not halfway between them. It's not down here. 60 is more up here. Now I draw my triangle. I notice that the x side is the shorter side of the triangle, so it's 1/2. And the y side is the longer side of the triangle, so it's √3 over 2. This is the first quadrant, so I don't need to add any negative signs. They're both positive. And then I go over x, up y to get to my point. So my x value is 1/2, y value is √3 over 2. And now in this problem, we're finding the secant of 60, which is the cosine value flipped. Cosine is my x value, so I take 1/2 and I flip it, and I get 2 over 1 or 2. And we're done. That's it. That's the unit circle. So let's try another one. Cosecant of 7 pi fourths. So first we need to know where 7 pi fourths is going to be. We know that 7 pi fourths is going to be in the fourth quadrant. And even more than that, it's going to be exactly halfway between the two axes, because it's pi fourths. Fourths is always halfway between. So we draw our point on here. Here's our unit circle. Kind of a poorly drawn circle today. So there's my 7 pi fourths. I notice on this triangle, this is my isosceles. The sides are the same. So that means both sides are going to be 1 over √2. And because I'm in the fourth quadrant, this one should be negative. So that makes my point 1 over root 2, comma, negative 1 over root 2. Now in this problem, we're looking for the cosecant, which is the sine value flipped. So we take our y value and flip it, and that gives me negative root 2 over 1, which would just be negative root 2. And those are some quick and fast examples of how we do the unit circle now. It all hinges on being able to visualize where that angle is. What quadrant is it in? Is it closer to the x-axis, the y-axis, or halfway between them? And then all we have to do is draw the triangle. Shorter side's 1/2, longer side's root 3 over 2. If the sides are the same, they're both 1 over root 2. Then we add our signs for whatever quadrant we're in, and we pull out whatever we need to. That's it. Now, C is a good one to do because it says cotangent of 3. Now the first thing we need to remember is that 3, is it an angle or is it a point? We know that 3 is an angle because it's inside the parentheses of cotangent. Anything that's inside the parentheses is your angle. Think of it up here with A, secant of 60 degrees, that's an angle. Cosecant of 7 pi fourths, that's an angle. Cotangent of 3, this is an angle. Now, even more than that, this is not just an angle, this is an angle that is in radians. I know it's in radians because there's no degree symbol. Basically, if there is a degree symbol, then you're in degrees. If there's no degree symbol, assume that it's radians. So, I know that a radians of 3, that is nowhere on the unit circle. There is no angle that is 3 radians on the unit circle. We have pi thirds radians, but not 3. So this actually is not a unit circle problem. This is a calculator problem. Now, the other thing you should know about your calculator can be in degree mode or it can be in radian mode. If you're not sure how to find what mode you're in, Google it for your calculator. Most calculators up in the top, they'll either have a D or a DEG if they're in degree mode, or they'll have an R or an RAD if they're in radian mode. So that will tell you what mode you're in. Then you can Google how to change your calculator between modes. That will be really important for this class because in this class you're going to use both modes on your tests. You need to be able to switch back and forth between them. Essentially, if you see a degree symbol, make sure it's in degree mode. If you don't see a degree symbol, then you're in radian mode. So get your calculator out, make sure you're in radian mode. If you're not, Google how to change it into radian mode. And now we need to put this into our calculator. You'll also notice that your calculator does not have a cotangent button. Now, it does have a tangent inverse button, tan -1, but tan -1 is not the same thing as cotangent. Those are different things. So, because our calculator doesn't have a cotangent button, we need to use our identities. So one identity I could use is my reciprocal identity and change cotangent to 1 over tangent. Because I know that the cotangent is the tangent flipped. So I could type that into my calculator, or I could also use my quotient identities and say that I know cotangent is cosine over sine, and I could type that into my calculator as well. And actually, both of these should give you the exact same answer. You can type either one in, and if you're in radian mode, you should get negative 7.015. And that's our answer. So that's an example of a calculator problem instead of a unit circle problem. Now, last one for this video. We want to find tangent of theta, where theta is an angle that is coterminal with 3 pi halves. Now we know 3 pi halves is quadrantal, and it's down here. So I take my point here. I know this point is going to be 0, negative 1. 0 in the x because I did not move side to side. Negative 1 in the y because I did move down 1 for the y. And then this is on my unit circle. Now I want tangent of theta. Tangent is y over x. So I take my y value divided by my x value. Negative 1 divided by 0. We can't divide by 0 in math, so this is undefined or DNE. Does not work. So there's a few more examples of unit circle problems using everything that we've learned so far. In the next video, we're going to do a couple more Pythagorean identity problems. So hopefully you remember the Pythagorean identity from last lesson. If not, we'll review that next.